Hey everyone, let's talk about how to spawn objects into Vellum. And so far what we've seen is that we have some clearly defined object that we want to simulate. For example, this piece of cloth, nothing special. But what if I want to constantly add something to my simulation? So some soft bodies, cloth, some noodles, some soft balls or something, you name it, and you want to constantly add this to your setup. What do? There's actually nothing built in here into the solver directly to do this. And obviously everything we would put in here would only be generated, so to say, on the first frame. What you have to do this is you actually have to go into the dive target. And this is something that is new in Houdini 19. You might notice that maybe in some of the older videos, I haven't re-recorded all of them. You will see that we mostly work with a force input. But there's another input called source that came with Houdini 19 for exactly that reason. So that we can actually constantly add during the simulation geometry to the simulation. So what we have to do for this is we actually use something that would be part of a custom DOP network. And let's quickly talk about this. This is actually something that used to be the only way to do this when you wanted to do this before Houdini 19. You had to create your own DOP-net, and it wasn't super complicated. Basically, you just had to build your own setup. Of course, what you needed was a Vellum solver, a Vellum object, and a Vellum source. So pretty much exactly how we know it from POPs. And of course you would add a gravity. And this would build you a basic Vellum setup. So if you feel like you want to do that, feel free to do this. It's not much more complicated than that. But what was special is that you had this Vellum source, of course, which is equal to the POP source that we learned. And here you have stuff like the emission type. So what we have to do now, and this is where this comes from, we can use this Vellum source now directly in the dive target in our preset SOP-DOP here. So all you have to do really is you have to define that you want to not emit something only once, but each frame, for example. And then, and this is important, you need two inputs, the geometry with the SOP path and the constraint, of course, because this is what we put into our simulation as well. So the thing is, you can theoretically combine this with an already existing input, but what I would recommend is to completely disconnect your setup here and maybe only keep the collision object, and then make sure that you will find those setups, because what we want to spawn is this planar patch again, but with the constraints that come with it. So what we would create is maybe something like out Vellum geo, let's say, and also an out Vellum constraint null, so that we can find this later. Theoretically, I think you could create something like this with a SOP solver or something, but it's much easier that way, because now we can say, okay, we just find our out null. So there it is, our out Vellum geometry for the first input SOP path, and then for the constraints that it needs, we use the out Vellum constraints. And now basically it knows the whole thing that it has to emit every frame, including the constraints, so that it behaves like cloth. So if I press start, you can see now it actually works, but there is a little bit of a problem, and that is it's way too many now, because what we're doing right now is we're emitting every single frame. Now this usually is not what you want. You want to at least a little bit of a gap in between, because otherwise you would spawn something like 24, 25 or 30, depending on your frame rate, pieces per second. That's usually too much. So how do you do this? Unfortunately, you can't kind of tell it here how many frames you want to use here, but we can use something that we've already learned actually, and that is the modulo. So if you're not sure, just search in the search bar for modulo, because this is something we used in POPs before, and we can do the same now here. And I want to, spare you the details, just watch the video how this works. But the idea here is that we can take the current frame, create the modulo from it, and let's say for every 10th frame. And this by itself will create, if we look at what comes out of this, and for now, turn off the simulation so it doesn't intervene. It just counts up until 9, and then it starts again and counts again until 9, and then 0, and again and again and again. So it creates a loop of 10 numbers that are repeating. The problem here is that's not what we want. We want this to be only activated in one of the 10 frames. So what we have to add to this is we have to check for one particular case. For example, only give me a 1 if the frame that comes out of the modulo is 0, for example. And then what we get is 9 times out of 10 the 0, and at some point, always when there is the 0 as the modulo, it returns a 1, and that means it activates the whole setup. So this is a trick, and it's exactly the same expression that we learned in POPs, so this should look familiar to you. And what we get out of this is, surprise, if we turn back on our simulation, it looks like this. And yeah, this way you can actually spawn a new piece of cloth from outside every 10th frame. And it's a bit weird that we can run this with an error up here, but well, that's just the nature of it. It actually works, as you can see. Now, to make this a bit more interesting, one last thing. Of course, the color that I gave it here would be nice if it would change for every piece, right? So whatever you put in, you know, it could be anything, not just a piece of cloth, of course. Keep in mind that you should change it for every frame ideally, so it looks more interesting. And we could do this, for example, by changing the seed that changes my random color. This, by the way, I set on detail, not on primitive or points. Of course, you can do this too, but I wanted one color for all of it. And here the seed we should change now, ideally every frame, so that every frame we get a different result. There you go. And now we have disco cloth. And if we take this disco cloth and look how this results in, of course, we will get a different colored. No, that didn't work. Why not? I think because we still have a cache here. Let's reset the simulation. It still doesn't work. Why not? Is the CD attribute coming through? Okay, it seems like for some reason it ignores the CD attribute. I have this guess that it has something to do with the detail class. Let's do it with a point wrangle, because this way we can actually use a seed for all the points. So all I have to do is we say the current color should be filled with a random, but the input is not pdnum or primitive or anything, but actually the current frame. So I'm sure there's another way of doing this, but you know, when in doubt, Vex is always a good solution. And here you can see now the difference to before is that we have a CD attribute on the points. Let's see if that helped us. Yes, that actually helped us. Okay, so the problem was I was only able to create colors for the whole thing that are random with a detail attribute with a color node. I didn't want that. I want to actually have the CD on the points, so I used Vex here. As an alternative, you could have used a promote to move the color from detail to point. As usual, I leave this kind of problem in. A lot of people like that when I run into problems. This has nothing to do with the actual Vellum spawning, really, but at least now we have seen how to solve this. And the cool thing about Vellum is, once again, this is something a couple of years ago would have destroyed your machine, because think about how many collisions are happening here every frame. And it's layers and layers and layers on top of each other. It's just amazing to see how well Vellum can handle this. It's awesome. So yeah. So anyway, this is spawning in Vellum and a little bit more problem solving on top. So I hope this is helpful. Thanks very much and see you later. Cheers.